Ferrari just released their SF-26, and in this video we're going to go from the front to the back of the car, analysing all the little aerodynamic details on it. For those of you that are new to my channel, I was an aerodynamicist for Mercedes for the 2018, 19 and 20 Formula 1 seasons, and I now work as an aerodynamics consultant, designing packages for race cars and OEMs in all different classes all around the world. Now this video of course comes with my standard disclaimer that no aerodynamicist can perfectly predict all flows by eye, so everything presented in this video is at best an educated guess. Now this car had some renders released of it and also a track outing. Now cross-referencing what I can see in the track images against the renders, it looks like the renders are largely true to life, apart from maybe there's some details that might be a little bit off at the rear of the diffuser. So for most of these images, I'm going to be using the renders to describe what's going on in the car, and then for the diffuser, I'll be using the track images. Now, starting at the front wing, we can see that we have a wing profile that is getting backed off towards the end, a bit like how we spoke in the Mercedes video, although they don't create as much volume in the cone in this region here. Now, one of the things that I've been pondering on since I did the Mercedes video was actually the direction of the vorticity off the top edge of the front wing end plate on these new cars. And one thing I hadn't really thought about was what happens when the flaps open. I've mainly thought about it as a flaps closed scenario. So when the flaps are closed, you have a high pressure on the top of the wing here. Now there's high pressure in front of the tire here, but on the test simulation I ran on a dummy F1 model at the end of last year, what I had was the wing pressure was slightly higher than the pressure in front of the tire, so we ended up with a roll-up going that way. Now, it's becoming more and more clear to me that that might not actually be the case on these cars, because as you back off these profiles, which I believe are more backed off than on my test model, this pressure here goes down. Now, if that pressure goes down, this pressure in front of the tire is going to cause a roll-up that way. Now, in that same vein, if we were to open up these flaps here with the active system, which is of course new this year, and completely back off those flaps, what would happen is that we would dramatically reduce this pressure in here. If we did that, we would almost certainly have a significant vortex roll-up going the opposite way to what I've been drawing in some of my previous videos. Now, when we have a look at the Ferrari's top end plate from the top down, we see there's really quite an outwashing shape. So if you trace that line there, you can see that it's really cranked in that angle there. And that would mean that if there was more pressure here than over here, we would end up with this cranked shape like that, producing relatively more vorticity and power and suction off the top vorticity than if we had just a straight shape. We've added camber to this profile and this will power it up. Now, this particular geometry could be there to try and make it so that you have a more effective front wing flap active delta. So with this top structure, anything you do here is obviously going to affect how the wheel wake moves further downstream. So perhaps when they back off these flaps, that structure moves the front wheel wake into a position where it's, say, impinging on the rear wing more for less drag, or maybe it just collapses a little bit more for less drag. And maybe that's how they're getting some extra drag reduction off the front wing using the active system. That's just a thought on what could be happening there. While we're out here, just looking at the shape of the footplate, you can see there's no fancy strakes or canards or anything out here. We just have a sort of channel through here, and then we've obviously got the outer vortex housing bit just through there. So no vertical strakes, nothing like that. Didn't see anything of that nature at the track, just this step in this region here. Now, it looks to me like what they're doing is that they're basically running an almost mini diffuser in this region, and this is going to cause more suction and power up on this side of the end plate lower. That could actually be used to slightly reduce the strength of the vorticity locally coming off the bottom of the end plate lower there and produce a little bit more here. So we're biasing the vorticity to this discretization over here. And that basically allows you to have multiple structures. Those structures would rotate and they would interact differently around the front tire and around where the squirt is coming in. Notably, with both this and the Mercedes having a somewhat similar top shape and the forward canard removed, I wonder if that is playing into that whole effect I was talking about with cranking this and getting more roll up over the top when the wing is backed off. If you had a canard here, it would just be a blockage when the wing is open. It would reduce the circulation around that top tip of the end plate. Looking down at the nose, we can see a more extreme interpretation of what I've previously discussed in terms of the supports coming out and then going into the nose. It's interesting that it seems that almost every team on the grid has opted for a solution similar to this, rather than having something come straight down as a pylon from the nose. I wonder if this is a consequence of all the teams trying to keep this nose fairly narrow, but then having to fit the pylon structure into the pylon legality box. And then, of course, what I've previously discussed in terms of having a clean junction to the nose in here to make sure that the losses at the junction are minimal. As mentioned before, having any sort of bend in the load path here is not structurally ideal, so this shape is really there for aerodynamic purposes. Moving further rearwards, we can see the Caketin runs a very similar philosophy to what Mercedes was running in terms of having that scoop in here like that, so that's the intake for the Caketin, and then having that big wheel shield go down the whole outside there. Now it's interesting on the Ferrari that the wheel shield has this shape like this around here. Like I've mentioned before, there's likely high pressure in this region compared to comparatively low pressure here. That will cause some circulation around here, which will probably result in some vorticity being shed off here and shed further downstream. So they're probably shaping this tip to try and house that a little bit better or control the shedding off that edge. Still in the front-on shots, you can see that water wing shape that I hypothesized was on the Mercedes, a little bit more clearer here. Essentially, you have this cut out, square edge, and then a notch back in. Like I talked about on the Mercedes, you're going to have high pressure on the floor here. You're going to shed some vorticity along here. That vorticity will run along the floor and produce a bunch of downforce. It will also work well with the vorticity that's being shed off the floor daggers over here that will be rotating in the same direction. So you get a full vortex system for the floor that is improving the downforce of the floor. And that's quite important because you have a flat floor here, no huge strakes at the start of it like we have in the current rule set. It's much more like the older rule set. Looking a bit further rearwards, you'll see that air intake shape is quite interesting. Essentially what you've got is you've got this little upkick here, and then it goes back with this little vein, and then it seems to go up and move around like that. So we've got this very clear divider here. I do wonder if this is a bit of what we saw in the previous regs in terms of having any chassis side losses captured by the inlet here so that you keep this flow over here as clean as physically possible. I'd imagine that's what they're doing, but they're just reworking this area so that works within the rules. It's worth noting too, though, that any structure like this with a high pressure region on the inside will cause some degree of vorticity to be shed on that edge spinning outwards. So there will be some vorticity along the bodywork. I can't imagine that that vorticity would be particularly positive in terms of its losses downstream. So maybe they're using it to help control any losses on the top surface of the floor, perhaps. Perhaps that's causing a little bit of local downwash onto the floor, and that's suppressing some losses on the floor top surface, but it's maybe not a huge development. Again, as with the Mercedes, we see these bulbous side pods, and the design on these is really quite similar to the Mercedes, where you've got a big stagnation area in here, which is going to be used to help push that wheel wake outwards. And then we keep the side pod wide, sweep it in at the rear, keep an undercut the whole way underneath, and that undercut feeds to a hole in the diffuser that is again very similar to the Mercedes. And then we have a little bit of downwash over the top, as well as downwashing bodywork further rearwards on the engine cover. Now, the floorboard on this car has a few interesting details. In terms of its general design, what we see here is a bit like the Racing Bulls floorboard, where we have these upwashing elements here, combined with an outwashing element in the forward portion. You can see very clearly from the camber on this particular outwashing element that it is outwashing, and there's a little bit of a wiggle in the leading edge that's obviously to align it with the onset flows. Now, one thing that is actually really interesting to me is how they've run their stay here. You can see that the stay goes all the way down to the foot instead of going to the vertical member. And they've also made use of that little tension tie that's allowed within the rules. Now, what's interesting here is that they did not put the stay up here or anything like that, which would be probably structurally better given there's a tension tie down low. So that tells me that they were trying to keep this tip up here as clean as physically possible. They wanted to make sure that aerodynamically, this section was getting the best possible flows on it, nothing blocking any flows going around the top, and they want to make sure that this shedding edge behaves well. In addition to that, they're probably trying to deal with the fact that the flows in this particular region could be moving in many, many different directions. So getting the alignment correct on that tie might be difficult compared to lower down. This is going to produce a vortex that's spinning this way. So we're going from the pressure side on this side to the suction side on the other side. So we're going around like that. So we're spinning this way like that. Now that's going to drive flow down this way, out this way. So that's going to presumably keep any outwash running along the forward floor, although it is a little bit high and probably not crazy powerful, but that's going to be a direction that I would imagine would drive more outwash and more extraction on the forward floor. It's also going to grab any tire wake that might still be sitting up here and pull it downwards. Now, similarly to the Mercedes, you'll see that we've got an upwashing curl along the floor edge that's essentially flapped by the upwashing floorboard there. So we're going to be extracting air out of this particular region here like that. We're going to be generating suction under the whole floor region here, and that's going to communicate around, much like we've spoken about in the previous video. One thing that's a little bit different to the Mercedes though is that instead of having a discretized curl along there, what they've instead got is a continuous curl. So the curl continues the whole way here, it drops down, and then it immediately goes into their floor notch where they cut the floor sideways and go along there, which is a bit different to the Mercedes where it goes curl up, down, a little bit along, and then floor notches in there. Now, all of this is just going to be playing the game of managing the vorticity that's cast off any of these edges, managing the upwash from this region and the suction that you can generate under the floor, and then how this all interacts with the floor edge back here and anything that's going to get ingested into the diffuser over here. Looking a bit further inboard, you can see that much like Mercedes, they are running the floor dagger setup, very similar to the cars of the era when I was in the game. And basically it's just these outwashing daggers like this, which I've spoken about on many different videos. Again, I'm kind of surprised that we're not seeing any more unique solutions, but maybe we'll get to see more as time goes on. Up top, the halo is all fairly vanilla. We've got a halo winglet to control any losses off the halo itself and to assist with downwashing air from the halo. Generally speaking, you want to use the halo to downwash flows as it helps with your rear end performance. And then in a similar vein, up around the roll hoop, we have two downwashing winglets just here. You can see those downwash there. That's going to be driving some mass flow down over the top. There's going to be some vorticity that's going to be shed like that, but I'm not sure whether or not they're adding this plate at the end to just improve the power of a relatively short chord element, or whether they're trying to position their vorticity high along here. But again, it's probably one of those things where adding downwash pretty much anywhere along the car in this region, generally speaking, does help with rear end performance. Looking back a bit, you'll see there's a serrated shark fin. Now, as I've discussed in my rules videos, there's not a huge amount you can do here, but because there's a surface that you have to shadow that's just here, and then your legality box is just up here, so there's really not much you can do here, and I'd imagine that anything you can do here is really quite subtle in terms of the aerodynamic implications. But what this shark fin layout would do is that if your car was in yaw and you were getting some sort of essentially crosswind along here, you would end up casting some vorticity across each one of these little notches. So it'd be a bunch of discrete vortices instead of one massive vortex system along here. These are fairly subtle effects because these little discrete vortices do end up combining into a full vortex system, but sometimes it can just be a little bit less lossy for the same amount of overall vorticity. And that is important to keep the loss down and controlled, because if you have a look, the rear wing is right here. So anything that's lossy that you shed off the shark fin is going to make its way into the rear wing. Looking at the floor corner, there's nothing too crazy going on here. I mean, looking at the track shots, it looks like this may be indeed their actual floor corner, but the track shots, their resolution isn't that great. Essentially, it's just two slots in like that. So like we've spoken about before, vorticity being brought under the floor there, clean mass flow being brought from the top down. But one thing that is slightly of note is that you do seem to have this edge here seems to sit a little bit wider than this edge here. I'm guessing that's going to be a vorticity positioning thing, although I would have thought it would be very subtle compared to just running them all at the same width. So maybe we'll see some movement in that area as the car development goes on. Now, the diffuser on this car is relatively interesting. You can see in these shots here that there is clear air through it, much like we saw in the Mercedes shots. And this one here is a really good one for seeing how far back the leading edge of the diffuser sidewall is. So you can see that the diffuser sidewall is back there somewhere, and there's a big cut along there, and then it comes down here. It's like the Mercedes cut, but it does seem to be a fair bit longer. Now, like I spoke about before, this big undercut side pod here, much like the Mercedes, seems to flow into this cut. So I'm going to guess that any clean airflow that's coming through this region of the side pod is going to be making its way towards this hole here. And that clean air could be potentially used to re-energize the flows on the inside of that diffuser sidewall, much like you would do with a multi-element wing. Or perhaps they're just looking to get as much mass flow into this region as possible because of that giant mandatory winglet that's on the side of the diffuser. It's going to just grab a bunch of lower wake and tire squirt and draw it in from the sheer amount of suction it's making and the vorticity that's coming off the bottom of it. This is a little bit more what I had in mind when I was talking about solutions at the start of the season compared to the Mercedes one, which is a little bit different to what I had pictured. One thing you'll see though that's a little bit hard to make out is this little element through here. Now, it's kind of hard to work out if this is the deflector off the Caketin or if this is just the mandatory diffuser winglet at this point here, but it looks like there's something that's more or less in line with the sidewall of this diffuser hole. Now, we really need better pictures to know exactly what's going on here, but maybe when that comes out properly, I'll do some analysis on that to see what's actually happening in this region. But I'd hazard a guess that there's an interaction between some form of effective inwash around the tire shoulder that's resulting in pressure around here from this element and suction around here. And that suction is going to communicate through that particular hole in here. It's going to communicate through there into the diffuser and help drive the diffuser mass flow. It's worth noting too that that diffuser has a really aggressive lateral alignment on that diffuser's intake for what's a relatively short throat behind it. Now, if you consider that this sidewall here of the diffuser intake is generally something that you want somewhat aligned to the flows underneath the car, you would have to assume that this diffuser is drawing quite a lot of mass flow in this direction here. And that means they're getting a fair amount of suction pulling through this diffuser there. That's a really outwardly aligned diffuser section. Now, I would hazard a very good guess that this is the shape of the diffuser underneath, because it doesn't super make aerodynamic sense for the flows that are coming along this way to then meet this surface where on the backside of this they have to drop down and come over it. Although it is worth noting that you could theoretically thicken the surface in this region here and smoothen that bit out. So anyway, I think that it's quite noteworthy that they're obviously generating a lot of suction in this particular region of the diffuser here. Looking at the rear of the diffuser too, while it's unlikely that this diffuser is truly real because it is, for a start, missing some strakes, we can see those FIA mandated winglets. So this whole shape out here that goes forward and then has elements like that that are all aggressively upwashing is all mandated by the FIA. And all the teams will have to deal with this particular shape, which is going to be causing them a lot of problems in terms of drawing a bunch of wake and squirt from the tires. Like, sure, the element would make a fair amount of suction because it's extremely cranked, but you kind of want the vorticity to be going the opposite way to what it is on this edge for good tire weight control. It's worth noting too that there's quite a lot of scallop in the rear impact structure, or RIS. It basically goes there and comes up like this. Now, I've confirmed this in the track images, so I'd say that they're trying to maximize that centerline expansion of the diffuser, and they'll probably have some rounding on that particular edge along there to allow any flows that are coming up through the centerline of the diffuser to go and deflect around the RIS. Looking at the rear wing, nothing too much to report on it, apart from the fact that, again, it runs a longer chord first element, shorter chord second and third, with a little bit of a wiggle on the top like that, which, again, like I suspect on the Merc videos, I'm going to suspect again that it's to do with the spoon shape on the main element that you can see in this view here, where there is a fair degree of spoon on that, and that's probably what's being reflected in that second element plan form. Like the Mercedes too, it looks a little bit backed off towards the tips with slightly larger slot gaps through just here and here. It is one of those things though where this does look a little bit more cranked than the Mercedes did. And that is my analysis of the SF-26. Well, that's all for this analysis video. If you liked it, don't forget to hit that like button and subscribe to the channel, as well as turning notifications to on so that you get pinged whenever I happen to upload a video. Leave a comment below on what videos you'd like to see next from me, and hopefully, I'll see you next time.